the previous video, we looked into the working of the acidic buffer, the introduction of buffer, the common and effect, and Le-Chatelier's principle. And I hope these things are clear to you. If you don't know about these things, if you have any confusion, you can watch my video back, search on YouTube, basic acidic buffer, Nandni Lakhwani, and it will come. Okay, so let's start basic buffer, right? So what is basic buffer? Basically, okay, basic buffer and basically, oh, it's rhymes. So basic buffer has a weak base, a solution of weak base plus salt of strong acid, right? Salt of strong acid. That is known as basic buffer in a solution. When a weak base combines with a salt of a strong acid, they'll form a solution basically that will be known as basic buffer solution, right? So let's have examples, right? Okay, so first example which we have is when, okay, let's combine ammonium hydroxide with, okay, ammonium hydroxide is basically a weak base, right? And a salt of a strong acid, right? So ammonium hydroxide is a weak base, salt of a strong acid. Let's combine sodium, okay, ammonium chloride, right? This is an example. We can have other examples too. Let's have a weak base which is let's have the same base, ammonium hydroxide. Let's combine this with another salt of strong acid which can be, okay, this can be ammonium sulfate too. Mm, this can be ammonium sulfate too, right? So these both are examples of this basic buffer. Weak salt plus salt of a strong acid, ammonium hydroxide plus ammonium chloride, ammonium hydroxide and this ammonium sulfate. So these both are the direct examples. Okay, now in my aesthetic video, I told you about that we can do any kind of reaction, and if we form this product, this can also be a basic buffer, or this can be an acidic buffer. So let's have these kind of examples over here too. For example, okay, we have this base sodium, okay, this is ammonium, I got confused. This is ammonium hydroxide. If it combines with let's have, this is a weak base, right? Let's have something called HCl, right? If these both do a reaction, what it will form? It will form ammonium chloride plus water will be formed, right? But in this condition, you must always remember that the what is it? Oops, I'm sorry for this. Okay, you must remember that the concentration of this chloride ions must be less than this. This concentration of HCl must be less. Concentration must be less of hydrogen chloride, so it can easily get cancelled out, right? The concentration of this HCl must be less. Uh, this concentration of hydrogen chloride must be less, right? So it can easily cancel. For example, we have concentration of ammonium hydroxide is 0.4. So the concentration of hydrogen chloride must be 0.1 or 0.2, So when this ammonium chloride will form, this concentration will be also 0.2, right? So when we will balance them, there will be concentration left 0.2 of this ammonium hydroxide, and on this side 0.2 of this ammonium chloride. So ultimately what we got, a weak base and a salt of a strong acid, like this we can get, right? Hope this is clear, because I've also taught you this in detail in my previous acidic one video, right? So let's start with example. Let's see the working of this basic buffer. Working of basic buffer. uh I do so much six, right? Working of basic buffer. For example, let's take this example: ammonium hydroxide plus ammonium chloride, right? So let's take a container over here. um mm, mm, this is a container, right? This is a container. It's a container, and let's add this ammonium hydroxide into this ammonium hydroxide. As it's a weak base, it will not completely dissociate, and ammonium plus there will be formation of chloride ions, right? And there will be equilibrium, there will be a reversible reaction. So basically there will be partial dissociation. There will be partial dissociation, right? There will be partial dissociation. Now let's say let's have, okay, we have this we have salt of a strong acid, which is basically this ammonium chloride. Let's break this ammonium chloride, and we have, okay, over here I got a mistake. There will be which, right? Okay, now there will be ammonium plus chloride ions, right? Now we have this is ammonium chloride, right? This ammonium chloride. Now there will be common ion effect, like we have studied. Now please remember that video. If you haven't watched that video, go back and watch that video first, then come here. Then, okay, we have this ammonium chloride. Now there will be a common ion effect, as this ammonia, both ammonia are same. Both ammonia are same. Okay, now let's add hydrogen into this. Let's add hydrogen into this. Hydrogen means we are adding acid into this. Basically, it's right over here too. By addition of acid, this hydrogen ions, by addition of hydrogen, there will be increase in the concentration. There will be hydrogen ion concentration. Don't we have arrows over here? Okay, so there will be high concentration of this hydrogen ions. So what will happen? This hydrogen ions basically will combine. These hydrogen ions will combine. These hydrogen ions will combine to this ammonium. Basically, these hydrogen ions combine with OH ions, and they will form water, right? So basically, this hydrogen ions will combine with OH ions, and they will form water. Now what will happen in the product side? There will be a decrease in the concentration of OH ions. There will be um, okay, there will be decrease there will be decrease in concentration of OHNs, right? So what will happen? This ammonium hydroxide basically will again react with this OH ions, and ammonium hydroxide will be forming like this. The equilibrium will shift to backward. There will be backward shift of equilibrium, right? There will be backward shift of equilibrium. Why? Because in the solution, like when the hydrogen ions were added, the OH ions combine with H ions and they will form water. So obviously in this reactant, this product side, a there will be less concentration of OH ions remaining because they are combining with water. Now according to Le Chatelier's principle, okay, I'm telling you that whenever there's a decrease in one side of the reaction, it will change the equilibrium. Like if there is increase in the reactant side, the reactant will be converted into the product will be converted into reactant. If there is decrease in product side, then the reactant will be converted into product. So over here there is there is decrease in OH ions, right? Now what will happen? These ammonium hydroxide, it will dissociate. Basically this ammonium hydroxide, right, will dissociate more. Sorry, I got mistake over here. um I'm unable to write. What is happening? Okay, what will happen is there will be decrease in the concentration of OH ions. This ammonium hydroxide will dissociate more, so they can give OH ions more. This ammonium hydroxide will dissociate more. Now what will happen, as there was a addition of hydrogen ions in the solution, this hydrogen ions will combine with OH ions and they will form water. So there will be decrease in OH concentration. Like so, after the decrease in OH concentration, now we want more OH. So this ammonium hydroxide will dissociate more, so to give OH ions. Now I hope this is clear to you. Now if we add hydrogen ion, what if we add OH ions into this, right? If we add base into this, basically what will happen, this OH ions will react with ammonia and they will form ammonium hydroxide. So this time now the ammonium hydroxide will not dissociate because the concentration of ammonium is also increasing, because ammonium is coming from two sides, from this ammonium hydroxide plus from this ammonium chloride, right? So there will be abundantly a high amount of ammonia, so there won't be any dissociation of ammonium hydroxide. What will happen basically, right? Let me write over here. What am I going to write? Okay, when the base will be added, the OH will be added, it will combine with ammonium, it will form ammonium hydroxide, and then this ammonium hydroxide will not dissociate because abundantly the amount of ammonia is also increasing, because it is coming from here, it is coming from here too, it is coming from both sides. So how it will decrease? It will not decrease because this ammonium chloride is a a strong electrolyte. Obviously, there will be 100% dissociation. So there will be abundantly high amount of ammonia. So this ammonium hydroxide will not dissociate and there will be formation of ammonium hydroxide. Right? So I hope this is clear to you. So ammonium hydroxide increase and there will be no dissociation due to common ion effect. Right? So I hope this is clear to you. If you have any kind of queries, you can ask me in the comment section. I'll be very glad to answer you guys.